So today, welcome back. We're going to talk about variables when they are on both sides of an equation. So how do we isolate a variable if we have variables on both sides of an equation? Well, first let's take a look at an equation. Here is x plus 3 and 2x. So this is x plus 3, there's the x, here's the 3, and here are two x's. So once again, the name of the game here is to isolate the variable, or get the variable by itself. So how can we get these variables by themselves? Notice we cannot add these together because the equal sign does not say add, so I can't add them together. They're not on the same level. So how do we handle this? We use the addition property of equality that we've been using throughout the chapter. What I do is if I take away an x on this side and I take away an x on this side, you'll notice I have 1x equaling 3. So what did I do? I subtracted an x from both sides. That created a zero pair, which eliminated the x and the negative x, and I was left with x equals 3. And that's pretty much the lesson. So let's check this out. If you have variables on both sides, we say get all the variables on one side using the addition property of equality. In a situation like this, notice I have 5x's on one side, 3x's on the other. So if I eliminate 3x's from both sides, that gets me a zero pair on this side. 0 plus 5 is 5. And over here, 5x plus negative 3x equals 2x's. So now it's just a two-step algebra problem. And we use the addition property of equality again to eliminate the negative 7. And we use the division property to isolate the x. And we have our answer. Many people will say, Mr. Thomas, does it matter if I eliminate the 5x instead of eliminating the 3x? And the answer is no. You'll still get the same answer. Check it out. So if I subtract 5x here, there's my zero pair. And on the other side, I have 3x plus negative 5x, which is negative 2x. When I use the addition property again to eliminate the 5, I end up getting negative 2x equals negative 12, and when I divide by negative 2, negative 12 divided by negative 2 equals positive 6. So either way that you decide to solve this, you will get the exact same answer. You get to pick. Here's another example. In this situation, we're going to do this problem because it's given. We're going to use the addition property to eliminate the 5x. 0 plus 6 is 6. When we look at the other side, we have 7x plus negative 5x, and that equals 2x. 2x plus negative 2 equals 6. If I use the addition property again, I can eliminate the 2. Now if I use the division property, the variable is isolated, and I get x equals 4. Alright. If I give you this one, you guys can try it. Once again, we eliminate from one side. We find that we add these together. We get a two-step algebra problem. We use the addition property again, and then we use the division property to be able to solve the equation. Can the problems get a little bit more sophisticated? Sure. Let me show you. Here's a problem right here, where you notice there are three variables, two on one side of an equation and one on the other. So, in order to be able to solve this, there's many different ways, but the way I'm going to do it is to find the things that are alike on one side. Notice, I can add these together because this sign right here says plus, so I can add them together. I end up getting 5h plus 6 equals negative 2h plus 20, and now I can use the addition property of equality to be able to move all the variables to one side of the equation. Notice when we add these together, we end up getting 7h plus 6 equals 20. Now it's a two-step algebra equation, so we use the addition property again to be able to get to 7h plus equals 14. And when we simplify using the division property, the variable is isolated, and we get our answer. Alright, so I hope this helps. Email me if you have any questions, and good luck, guys.